All right, guys. Welcome back from spring break. I know it's kind of weird what we're doing here, but it should work as the same. If you do need help, please reach out to me either through email or I'm also on Google Hangouts. We can like video chat so I can show you how to work out a problem. Whatever works best for you, I'm here to help you. So we're going to go ahead and get started with today's lesson, which is on adding and subtracting rational expressions with common denominators. So hopefully you've printed off this worksheet so you can follow along with me and help you out whenever you get to your homework. So before spring break, if you can't remember, that was 2 weeks ago, we learned how to simplify fractions like these, and then we also multiplied and divided fractions. So it's only it only makes sense that we're going to be adding and subtracting them now. So this section is pretty easy because we're going to be adding things that have common denominators. So it's not too difficult to do that, because if you think about normal fractions, I've got an example of that. Remember, when you add fractions, they have to have common denominators to add or subtract. And when you have common denominators, you just do what the numerators say. So this says do 6 plus 2. So 6 plus 2 is 8, so you get 8 over 5. Notice, remember, when adding and subtracting fractions, the denominator does not change. You just do what the numerators say. So here's another example. If it's 9 over x plus 2 plus 3 over x plus 2, the denominators are the same, so we simply add the numerators over that common denominator, and 9 plus 3 is 12 over x plus 2. And remember, we can't simplify these 2 and 12 because you can't simplify across addition and subtraction. It's got to be a factorable thing to simplify. So what we're going to be looking at in these examples is, again, fractions with common denominators, and then we're going to be sure to look for factorable things to simplify to our final answer. So we'll see some examples of that. So number one, we've got 5m over 2n plus 1m. I'm going to put the understood 1 there over 2n. So I've got that common denominator, so I go ahead and just make a new fraction with that common denominator of 2n, and then I do what the numerators say. 5m plus 1m is 6m. Then we just have to look at our answer, and does it reduce? And this one, yeah, it does reduce. The 6 and the m are being multiplied, the 2 and the n are being multiplied, so they're factors, so that means I can simplify the 6 and the 2. 6 and 2 are both divisible by 2. If you divide by 2, you get 3m over 2 divided by 2 is 1. I'm not going to put the understood 1, just the n that's left over. Number 2, again, we've got common denominators, so I'm going to put it over my denominator of 2y minus 7, that's in common, and then I look at my numerator, 2y minus 7. So think about that, 2y minus 7. Those don't really go together, so we just rewrite it as 2y minus 7, because they don't really combine. And look at that, does it reduce? Well, it looks like I have a 2y minus 7 over 2y minus 7. Well, something over itself is always going to be 1. So that one just simplifies to 1. See, number 3, again, I've got 3x squared plus 2x over x minus 1 minus 10x minus 5 over x minus 1. So again, I've got those common denominators. So I know I'm going to have that denominator of x minus 1. And then I have to do what the numerators say. Now here's where the mistakes are going to happen. Whenever you subtract a fraction that has more than one term, you have to distribute that negative. So this is, if you make a mistake, this is probably where it's going to happen. So we're going to distribute that negative, and this is going to become a negative 10x, and a negative times a negative is a positive 5. So I'm going to kind of simplify that into the negative 10x plus 5. And now I just combine like terms. So I look, and I've got 3x squared plus 2x minus 10x plus 5. Well, obviously the only two things that are going to go together are the positive 2x and the minus 10x. So the 3x squared would be rewritten. 2x minus 10x is negative 8x. And then I've got the plus 5. Okay? And then again, so this one is one where I have to be sure to look for factorable things. So I look at this numerator and I have to see if it factors and see if it would cancel out with this x minus 1. So this is one of those magic number cases where I've got to look, what's 3 times 5? 15. So 15 is my magic numbers. Are there factors of 15 that add to 8? So it's either 1 times 15 or 3 times 5 for my factors of 15. And clearly, 3 and 5 add to 8. So that means this is going to factor, so it might reduce. So I'm going to break that negative 8x into a negative 3x and a negative 5x, because that's still negative 8x. The other things get rewritten. Remember, we made this 4-term polynomial on purpose for a reason, to factor it by grouping. So we group the first two, and we group the second two. And that first two, what's in common? Both of these are divisible by 3x. So I'm going to come down here. If I were to divide each of those two terms by 3x, what would be left? Well, 3x squared divided by 3x is x. And I've got the minus sign. 3x divided by 3x is 1. Then I look at my second group. What's in common there? We don't want our first term to be negative, so we're definitely going to factor out a negative. And then both of these are divisible by 5. If you divide by negative 5, you're going to be left with x and minus 1, which is great because those two parentheses match, which means I can factor out the x minus 1 that's in common. And the leftovers that I have in red would be 3x minus 5 for my second parenthesis. And then don't forget, this was all over that x minus 1 originally. So then we look, does this simplify further? Absolutely. The x minus 1's cancel, leaving me with a final answer of 3x minus 5. So we see we get a lot of those things that we've been doing before. We're just taking one small step at the beginning and then a bunch of review at the end. If you want to pause the video here and work through 4, 5, and 6 on your own and try those, you might be able to do that. Actually, just 4, you might want to pause and try 4. 4 is a lot like number 3, and then 5 and 6 are kind of like each other. So try 4 if you want. If you want to pause the video and try it, go ahead. And then I will go ahead and continue working it. Okay, so let's see. First thing, again, I've got that common denominator of x minus 1. And then I remember that if there's a negative, it has to distribute to both of the terms in the numerator. So it's going to be really a negative 6x minus 3. So I'm going to kind of erase that and just look at what I'm dealing with. And then like terms, I would still have the 5x squared. 4x minus 6x is negative 2x. And then I've got the minus 3 again to be rewritten. So again, just like number 3, we need to check, does this factor? So once again, my magic number is 15, 5 times 3. And then I'm looking at the factors of 15 that subtract to make negative 2. So again, my options are 1 times 15 and 3 times 5. And again, 3 times 5 this time subtracts to make negative 2. So how can I arrange 3 and 5 to make negative 2? Well, that would be a positive 3x and a negative 5x, right? That is still the same as negative 2x. So again, remember, we break down that middle number into those two factors that make negative 2. And then the other things are going to be rewritten, the negative 3 and the 5x squared. And we created that 4-term polynomial on purpose for a reason, to factor it by grouping. So we group the first two and we group the second two together. Look at the first two's group. What divides both of those terms? Again, just an x. If you divide by x, you're left with 5x plus 3. If you look at that second group, you don't want your first term to be negative, so you're definitely going to factor out the negative. And then there's nothing else really in common, so I will put the understood 1 that we're dividing by. If you divide by negative 1, you're left with 5x plus 3. Those parentheses match, so we know we've done it correct, so that's good. And it would factor to the 5x plus 3 that's in common in blue, and then the leftovers in red, the x minus 1. And then don't forget, this was all over that denominator of x minus 1. And maybe I'll even put it in parentheses this time. now we see that those x minus 1's definitely match. They're exactly the same. So they cancel each other out, leaving us with an answer of 5x plus 3. Okay, so hopefully you did well on that. 5 and 6 are similar, so I'll do 5, and then after 5, if you want to pause it and try 6, let's see if you can get the correct answer. So again, I'm looking at 5. I have this minus that. I look at the denominators. They're already the same. So I would put it over that common denominator of a squared plus 2a minus 15. And then my numerators, 4a minus 12. Well, there's really nothing that you can put together there, so it's just going to be 4a minus 12. Now we look at that answer and we might think, that's probably my final answer, but that's probably actually not the case. This numerator definitely factors, and this denominator will probably factor as well. So we have to factor it. So look at the numerator. It's not any difference of squares or anything, but it has a GCF of 4. If you divide by 4, you're left with a minus 3. So there, the numerator is nice and easy to factor. The denominator is also nice and easy to factor. I don't have to go through the magic number scenario because there's no number in front of the first term, right? It's just a single a squared. So remember, then that's the case, we can go directly into our 2 parentheses. We don't have to go through all of this magic number scenario. So we know that we're going to drop an a in the front of both parentheses. If my third sign is negative, that means I'm going to have a plus and a minus in my parentheses. Remember, if that third sign was positive, we use the sign of the second for both. Okay, and then once again, we're looking at the factors of 15. So they are 1 times 15 and 3 times 5. Seems to be a popular number today, is 15. I'm looking for the factors of 15 that subtract to make positive 2. So once again, I'm going to be using 3 and 5, but I need it to be a positive 2. So that means I would have a positive 5 and a negative 3. So now it's completely factored. Then we just got to look, does anything match? And absolutely, the a minus 3's match. So it looks like I have a final answer of 4 over a plus 5. And you don't have to have the parentheses around that because it's the only thing left, but you can put them if you want. So if you want to try 6, it's pretty similar to 5. If not, you just watch along. Otherwise, try it, pause the video, and see how you do. So 6, much like 3 and 4, remember that negative has to distribute whenever there's more than one thing in that numerator. So if I distribute that negative, it's really going to be a negative x and a positive 2. So then I'm going to kind of cross that out. Again, look, the denominators already match, so go ahead and make that common denominator of x squared minus x minus 30. And I'll do what my numerators say. 2x minus 1x is 1x. And 3 plus 2 is a positive 5. Okay, so we look at that, and like 5, we probably can factor some things. The numerator, there's nothing in common, and it's not a difference of squares or anything like that. So that is going to stay as x plus 5 for my numerator. In the denominator, it's much like 5 where I don't have that number in front of the first term. I can just go straight to the parentheses. These ones factor very quickly and very easily. So I know I'm going to have an x in the front of each parenthesis. Again, my third sign is negative. So that means I'm going to have 1 positive and 1 minus inside of those parentheses. And then I look at the factors of 30. They are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So I'm looking for the factors of 30 that subtract to make the understood negative 1. So clearly it's 5 and 6. And it's got to be, to make a negative 1, it's got to be a positive 5 and a negative 6. And we look at that. Does anything match? And you say yes, the x plus 5's match. So then remember what happens if I cross out everything in the numerator. There's an understood 1 up there. In the denominator, I still have the x minus 6. So there's your front side. Hopefully you did well there. Oh, look at that. There's nothing on the back. So that's all we have for you today. So again, if you have questions on your assignment, please reach out to me. Look at Google Hangouts, and I can pull up my document camera and help you work through a problem. Whatever you need, just make sure you're getting the help you need, all right? I'll see you later.